We are 2 site reliability engineers in Israel on a team of 16 site reliability engineers from the United States. We work at a company called ZipRecruiter. Most of you might know who we are. How many know who ZipRecruiter is? How many know who ZipRecruiter is because they've been listening to podcasts? Yeah, we tend to advertise a lot on podcasts in the United States. Our company's main business is in the United States and in Europe, so that's probably why you haven't heard of us here. This is Dan Yelovitch, and you can see him eating a bamba, the Israeli Dan Yelovitch. I'm an American, so I'm eating a donut. So it's the Ultimate Warrior versus Hulk Hogan, the poly-repo versus the mono-repo. Who is going to win? Well, actually, I don't really want to talk about who's going to win. I don't think that, it's a very religious fight, this fight, and that's actually not our purpose here in this talk. What we are going to talk about is how we use a mono-repo at ZipRecruiter and how we use the good things of a poly-repo and put it into our mono-repo. Mono-repo being one repository for all apps, poly-repo being one app per repository.
So, several years ago, I joined as an SRE in ZipRecruiter. And as a young hotshot SRE, with head full of air, I immediately wanted to leave my mark. So I was looking around to see where I could make the biggest impact. And I saw the logging, and I thought maybe I could streamline the logging. And then I realized, no, the logging is already streamlined, centralized, and we have a whole team dedicated just for that. What about 12 factors? Everybody loves 12 factors. Let me help them implement it. No, ZipRecruiter already implemented 12 factors. What could I do? What could I do to make a difference? And then I saw it. The mono-repo. It was old, over-engineered, complex, and didn't fit any of the buzzwords like microservice. So I saw my mark, set a meeting with the powers that be, and I laid down my proposal. Let's start splitting things off the mono-repo. Let's be faster. And they looked at me and said, no, we actually love the mono-repo. Yes, it is complex, but this complexity propels us forward. This complexity of the mono-repo helps ZipRecruiter scale. And I was confused, to say the least, because mono-repo helps the company scale? That sounds counterintuitive. So I needed somebody to explain it to me. And they said, in order to understand that, first you have to know the story of ZipRecruiter.
So ZipRecruiter was founded a long, long time ago in a galaxy far, far away in 2010 by 4 founders who basically wanted to match quality candidates to employers. Basically, they were an online job marketplace. They could out-iterate their competition because they were small and nimble and could move fast. They could communicate one with the other. Communication channels were very, very clear. And the reason is everybody was sitting in the same room. There was a sense of shared responsibility. Those were basically our core values. And that's what they wanted to keep at ZipRecruiter. As most startups actually, they were a monolithic app. Most startups start as a monolithic app and not a microservice, a common misconception. And the reason why they started as a monolithic app, I'd refer you to Martin Fowler's blog, Monoliths First. And basically, microservices need a lot of plumbing to get them to work. And it's better to put your resources and your efforts when you're a small startup into bringing business value as quickly as possible. But as things get more complex in that monolithic application, things slow down. So we decided to split our apps, or slowly split our apps from the monolithic application, and then also split our apps from the monolithic repository. Anybody can guess what I'm trying to talk about here in terms of an application? Okay. Never mind. Tried. So we manage our AWS infrastructure we used to manage the AWS infrastructure in this fantastic way. It's called the AWS console. It's one of the best applications ever. Unfortunately, that doesn't scale very well. Human error. So what we decided is actually to move from manual configuration to Terraform. In order to manage Terraform, we decided let's put it in another repository. The reason is us as site reliability engineers wanted to put controls over Terraform so that developers don't shoot themselves in the foot. By the way, this is the second Hulk reference, different type of Hulk. So we continued to grow. 2.5 years ago when I started at ZipRecruiter, we were 200 developers and 500 employees. All aspects of the business started to grow. So we wanted to split up some more things. We had our own internal configuration management tool. Fantastic. Highly recommended to build your own configuration management tools yourself. It's a really scalable way to do things. But we realized, we're not in that business really. So let's adopt something that is out in the market and works. So we adopted Salt. And to manage Salt and, so that developers really don't shoot themselves in the foot, we decided to put in another repository, put controls over it, like, a site reliability engineer should do.
So we started to ask ourselves, yes, we were growing, but actually we're becoming less productive. We were releasing less and less, and the SRE team actually became the bottleneck. So when we started, the SRE team became the bottleneck. Actually, instead of developing the infrastructure, we became the gatekeepers to it, and we were just bogged down with all the toil around it. So not only that, but the problem actually grew worse as the company grew bigger, because developers don't scale at the same rate as the SREs. So what can we do to solve the problem? How can we let the infrastructure team catch up? Maybe we should hold production for a while and let the infrastructure team actually catch up. But no, that's a bad idea. At best, it's a patch, and it actually doesn't scale. So we needed to actually solve the problem of how to scale ZipRecruiter. And then we understood that, yes, we actually scaled our code base. We actually scaled our technology, but we lost our culture in the process. And we needed a way to keep our culture at scale. So today, ZipRecruiter is scaling faster than ever, with over 1,000 employees in 3 sites, the US, the UK, and Israel, over 350 developers in over 30 teams, and we are deploying faster than ever, because instead of weekly deployments, we are doing multi-deployments per day. Now, the mono-repo is not the solution for that, but it's a very useful tool that can help us keep our culture. And let us explain why. First thing, collaboration. Collaboration is easy in a mono-repo because everything is in one place. But how does that collaboration help us? Well, ZipRecruiter as a company faces many issues every day. And these issues change every day. Sometimes they grow bigger. Sometimes they get resolved. Our team structures needs to be able to reflect that. So our teams can change, can be split apart, can be absorbed into other teams as the problem they are facing. It's easier to do that because everybody shares the same code base. But not only the company faces the issue, also developers faces issue when they're trying out our development flow. So we encourage all developers to meet once a week and discuss together between developers, between different teams, issues that they see, and they try to resolve it together. Later on, we'll discuss some of the tools that came out of these meetings. But what about dependencies?
How many of you like to manage dependencies? It's one of my favorite things to do in the world. Dependencies suck, and they're very hard to manage. We have 2 different types of dependencies, like all you guys do. We have third-party dependencies and our internal dependencies. For third-party dependencies, we manage it much like most people do. We use an artifact repository. In our case, we use Artifactory for our Java third-party libraries. And the one thing, though, is we try to pin as little as possible. One of the things that we always try to be on latest with all our code. So that's the external artifact repository. But for our internal stuff, we actually check in all our dependencies into our code base. We believe in source dependencies over binary dependencies as much as possible, because then we're always on latest. We're always building latest. This gives us an easier way to debug things, because everything is right there in that one big repository. Not only your app, all your dependencies as well. And it also makes the code a lot easier to audit. So our monolithic repository is our source of truth. It's our source of truth for a couple things. So one of the things is it's our source of truth for our applications, but it's actually right now, not like what I showed you a few slides ago, it's also our source of truth in terms of our infrastructure as well. Everything can be traced back to a single commit. So we practice GitOps. And why is that good? Because everybody can discuss what's happening in production by looking at production's commit that explains the whole entire infrastructure. In a polyrepo, what you'd probably do is every single application has its own commit, because every single repository can be traced back to that to a commit, and then you'd have to have some complex mapping to get any knowledge of what's actually happening in production. We can always refer to that single commit. Makes things a lot more auditable as well with GDPR and the California Consumer Privacy Act. Those are regulations that we're right now. Well, the GDPR we already did, and California Consumer Privacy Act we're right now implementing. It makes it really easy for us to actually create a place where we can be audited, and it makes the auditors happy because they have a single place to look at themselves. One of the problems in a monorepo that you have a lot less in a polyrepo is the ability to actually have long-lived branches. In a polyrepo, as your application diverges, as you create a feature branch and your application slowly diverges from your feature branch, it isn't that difficult to merge things. But in a monorepo, when you diverge from master, you're diverging from all your applications and all your infrastructure. So the longer that you do that, the harder the merge is. So enter short-lived branches. Short-lived feature branches are great, actually. They're not that bad because guess what? We can deploy more often as well. So another thing, as site reliability engineers, we own our production. Well, we don't actually own our production environment. We are subject matter experts on our production environment. We actually don't own it. We don't want to own production. We want all our developers to own production. Actually, more specifically, all our developers that are on call own production, because those who are not on call do not get paged and do not have to deal with issues within production. But that's actually most of our developers. We have centralized logging. We have team-based monitoring that everybody can look at, actually. And we have an active Slack channel for any production incidents that we have. Everybody gets woken up by PagerDuty, whether it be an application team. If their application breaks, that application team gets woken up by PagerDuty, or the person on call for that. And when infrastructure breaks, we get called for that. Actually, with one caveat, one of the advantages of working in Israel and having an American team is that we follow the sun.
So we don't only share responsibility for production, we also share responsibility for the code base. And let me give you an example for that. Let's say that the SRE team wants to upgrade its tools to use the latest Golang code base. Sounds simple, right? We update the code base, we update the tools, we update the test. Easy peasy. But in a monorepo world, this has just become a bit harder, because I didn't just upgrade my code base, I updated all the company's code base, and I updated everybody's test, and I broke everybody's tools. Wow, what a pain. I didn't want to do that. And yes, it is a pain. But this pain is good for us because it forces us to think outside of our component sphere. Yes, we have to be aware of other teams that use our code base, and we have to take into consideration their requirements. Not only that, we also have to be very communicative about it because you don't just break somebody's tools without telling them. We also have to be good listeners because people announce changes, and if we don't listen, our tools will break without us knowing. So let's talk a bit about things breaking. As in every company, we have production incidents all the time. And as your product becomes more complex, so do the production incidents. And you don't only have to solve the thing that paid you, you also have to find the root cause of what actually broke and fix that. Well, as in a mono-repo world, it's easier to investigate these issues because, well, first thing, it's a mono-repo. All the issues happen in one place. It's easy to look for them. Not only that, we encourage the developers to be as descriptive as possible in their Git commits. So not only do I know what broke and who broke it, I also know why he broke it, and I can help debug the issue faster. And last but not least, because we change our code all the time, if something broke today, it probably changed yesterday. So I don't have to go through months of histories of Git commits to know what exactly changed. This is good for us because the production incidents are resolved more quickly. And since the production incidents are resolved more quickly, they have less of an impact on our production environment. Why is that so important for us? Because in ZipRecruiter, we have a KPI to measure success called mean time to ID tested. Basically, how long does it take for an ID to be thought of until it can actually be tested on the server? We want the process to be as quick as possible, so because of that, we gave as much control as we can to the developers themselves. Controls over infrastructure like Terraform. Let's say that the developer wants a new S3 bucket. Does he have to open a ticket for the SRE to create it for him? No, that's making us the bottleneck. We gave the Terraform attribute to the developers and we tell them, enjoy, run it, this is your bucket, you own it. What about deploying to production? Should the SREs be the production engineers and deploy everything to production? Again, no. We have an automatic CI/CD pipeline which is triggered by the Git commit. So any developer can push to the branch and he deploys his app. Okay, that sounds a bit risky. And yes, it is risky because developers have a lot more power to break the production. But this is a risk we are willing to take because first thing, we minimize the impacts by having faster production incidents, which are resolved more quickly. Second, we reduce the blast radius of these mistakes by having a very strict directory structure.
Anybody practice this type of folding technique? I do too. Yeah, Marie Kondo. Great. So what actually does this have to do with mono-repo versus poly-repo? Well, in a poly-repo, it actually is fairly easy to be organized because all you're doing is based around your own application. In a mono-repo, you can have a disorganized mess really, really easily. So how do you prevent that? Well, you put structure on it. You put structure. We do it with convention over configuration, giving us the ability to create tooling such as Git hooks, linters, and other tooling to enforce policies. Why is that good? Well, let me show you exactly our directory structure, or actually just a part of it. Okay, so what you see at the top level here, can you all see this? Kinda? I'll talk you through it. At the top level, there's this directory called CI/CD. The directory called CI/CD in our terminology is called a theme. A theme, not a team. Teams can own one theme. Multiple teams can own one theme. And that actually can be dynamic and move between teams as well. Underneath that is our actual application. This application here, under our CI/CD directory, is called the professor. Under the professor, we have all that the application needs in order to run. We have under config, our config directory is used to basically manage any configuration for any environment that we have. Underneath that, we have infrastructure. So any AWS resources that we need, that's going to be managed under Terraform. Notice Terraform was outside of our repository. We moved it right back in, and we actually moved it in to a place that every single team can own themselves, not the SREs. Underneath that, you'll see manifests. We moved from Salt. Configuration Manager is great. It's a lot easier to manage it within Kubernetes than it is on EC2 instances. So under manifest is how to run our workloads in Kubernetes. And underneath that, we have a whole bunch of other files. One Docker file. We're building an application for Kubernetes. It's going to be Dockerized. And notice the Docker file deps file. What it has underneath it is a list of a whole bunch of paths. I'll discuss that later.
So let's talk about the elephant in the room, the security issue. Yes, we have sensitive code in our mono-repo. That sensitive code is mostly financial and security code. And all developers can read it. Cool, right? Yeah, everybody can read it. But all developers can actually also edit it. And that's not so cool, right? We want to protect our sensitive code. So what can we do to protect it? I have an idea. How about we take all this sensitive code, put it in a different repo, and put controls over that? No? We tried that. It didn't work well. We need something else, something that's good for us. How about using our directory structure? How about next to each sensitive code stack, we put an owner file. That owner file will list all the developers that can change the code or approve changes to it. Sounds cool, right? Sounds correct. How do we enforce it? We're going to talk a bit in a second. First, we have another problem. And that's publishing our Git branches. Yes, I'm going to use this GIF like only once because I was told it was very distracting. So, yes, we want to publish our branches to the mono-repo. How do we do that? Well, first thing, in ZipRecruiter, in ZipRecruiter, we want to have a linear history. So in order to do that, we do a rebase, right? What does that do? That actually creates a race condition between us and the other developers. Why? Because in order to do the rebase, I have to be the last one to do the push. Now, it's annoying with 100 developers. It's very, very tough with 350 developers. Imagine doing that over the VPN. Yeah, you can win that race, right? It got so bad for us at some point in time that we actually, whenever I worked from home, I didn't even try to publish my branch. I just pushed it to the origin and sent a Slack message to a team and said, hey, please publish my branch whenever you want. I can do it from home. So we needed to solve this. This actually became worse as we scaled up. Well, in order to solve that, we created a tool called Greenlight. And we saw the effect of Greenlight right away. Because before, these were our instructions to publish our branch. Not that bad, right? Like, imagine doing it several times a day, not so much fun. After Greenlight, these became our instructions. Simpler, right? Nice. So how does Greenlight do this magic? Well, Greenlight is basically a branch merging tool. All it does is sit somewhere on a server in our infrastructure, wait for a merge request to happen. When it does, it pulls in the requested branch, rebases it to master, and pushes it. Doesn't sound that complex, right? Really easy. It also has another feature. If the requested branch has a commit that affects a code stack with an owner file, it will pause, send a message via Slack to the owners, and ask for their approval. Nice. We already got security and code review. Lovely. What about the race condition? The race condition is also solved because now my pushes happen asynchronously. They don't happen on my time. I don't have to worry about the race. Greenlight does it for me, and it does it whenever it wants. Basically, I do the push to the Greenlight request, go make myself coffee, and by the time I get back, it's already there. How lovely is that? And you know the coolest thing about Greenlight? Although it's maintained by the SRE team, it wasn't created by us. You remember before I was talking about days where developers can meet across team and discuss issues that they are facing? This tool is the brainchild of these developers.
So let's talk a bit about build and deployment. Our repo size is 2 gigabytes. That takes 40 seconds to download. The number of builds are 691 times 3. Why times 3? Anybody? Good. You got it immediately. Shows that you guys work, which is good. So we have 3 environments. We have dev, stage, and prod. And so that's great. 2 gigabytes. We can easily build one build very easily. But what if you have 691 builds times 3? That becomes incredibly resource intensive. So how did we solve that? Well, we solved it through some caching and through some cake as well. So let's talk a little bit about caching. There's a bunch of different ways to do caching. Let's start on the Docker side of things. We cache via base images. We have a base image for our operating systems. We have, on top of that, a base image for any language that we develop on. We develop, believe it or not, in Perl. We develop in Python, in Go, and in Java. In addition to that, so on top of that, we have multi-stage builds as well. And multi-stage builds basically do some caching. Well, actually, before that, the Docker file itself has some caching capabilities as well. This fantastic layering component called, anybody know what the layering component's called? Layers, right. They came up with a really good name for it. And then on top of those layers, we use multi-stage builds. Multi-stage builds are basically a pipeline of builds within one Docker file. So you have a image that is getting created by one bit of the Docker file, and then then the next part of the Docker file grabs the artifact of that first image and onwards and onwards. And that also uses layers as well. And now on the build side of things, on the actual build server side of things, we use Jenkins. On our Jenkins agents, we have a bare repository that syncs up with our main Git repository on each one of these agents in order to actually cache that 2 gigabytes every single time as well. And so that happens asynchronously as well. In addition to that, we have some tooling. Anybody know what Stevedore is?
Stevedore, you used to use it in Python and Celery.
No, not the answer. Great, but it's actually an internal tool of ours. I'm thinking of the terminology, Stevedore.
The guy that on the sheep thing,
Yes, it's actually, by the way, I just found out a couple days ago that it's actually a synonym for Docker. Because Docker is the same thing in the end of things, which is kind of cool. So Stevedore is our Swiss Army knife of build tools. It manages our dependencies. Remember that Dockerfile deps file that I showed you earlier? Those paths in the Dockerfile deps are basically all the paths of the dependent libraries that you need in your application. So the way that Docker works, as many of you know, Docker, when you build something, you build from one location all the way down. You can't actually build a parent of your directory that you're in while running it. So Stevedore, the first thing that it does is it reads the Dockerfile deps file for any dependencies that it has. Because guess what? All our dependencies are in source. So all our libraries are in source as well. And it basically creates a transitive, for anything for the dependencies and then the transitive dependencies as well, creates a graph or whatever it might be, and sticks a Docker ignore on everything that's not within that. Okay? Why is that? Because if you build at the top level, it's going to take a long time just to scan all the files that you have there. So it saves a lot of time there. But it also does another thing. You're only building what you actually want to build. So if you do a Docker, in a Docker file, a copy, dot, you're only copying what you've actually defined within your Docker file deps. So another thing that we have is during our build time, we have another tool called Jenkins Auto Build. Very original name. Stevedore is a lot more of an original name. It's pretty much the only tool that has a non-original name in it. So the Jenkins Auto Build surprisingly does builds. And what it does, it calls Stevedore match. Stevedore match uses basically a git commit range and finds all the apps that are needed to build based on the commit that happened. And that is done via the Dockerfile deps.
Okay, we talked a lot about our internal tools, but what about third-party tools? They are great, right? Everybody loves them, especially if you're a startup. If you're a startup, third-party tools are like magic. They come and solve the issue. But like Rumpelstiltskin or Utsy Gutsy has a saying, all magic comes at a price. And so do these third-party tools. And what is the price for them? We have to remember that they were created with different assumptions than ours. So when taking these third-party tools, we have to ask ourselves, will they fit our infrastructure? Will they scale with our infrastructure? Yes, we don't only have to consider the outcome, we also have to consider how much pain it takes to grow. Now, I'm not saying do all your own tools yourself. There is a lot of room for tools that are out there and open source, and we can use them. But look, for instance, on the story of Greenlight. As I said, Greenlight is a branch merging tool. This is not a new problem and not a unique problem to ZipRecruiter. A lot of companies face this, and some of them even open source the tool. Why not use theirs? Well, basically, we wanted something that fits our needs, something that uses our directory structure and enforces our owner file. There is a room for both third-party and internal tools. If you look at our CI/CD flow, in the next slide, you can see it's a tapestry of both third-party tools and our internal tools. Third-party tools like Jenkins. Everybody loves Jenkins, right? But we wanted Jenkins to actually expand on our manifest files. So we attached an internal tool called Epoxy. What about ECR? We are an AWS shop, and we love using ECR to store our images. But we wanted the ability to upload images to only one ECR, and from there have it synced to all the relevant accounts. So for that, we created a tool called ECR Sync. I think what I'm saying here, and when considering third-party tools or internal tools, you always have to think what will make the biggest impact with the least amount of effort.
So we are not only consumers of open source, we create some open source ourselves as well. Open source doesn't really fit well with a mono-repo. It doesn't fit in well with the mono-repo because let's check in our open source into our monolithic repository and then expose it actually to the rest of the world. Okay, guess what? We just exposed our whole entire mono-repo to the whole entire world. Not a very good thing. So what we did is we have an external repository that actually, external repositories that manage all our open source. The problem is that doesn't fit our whole mono-repo approach, does it? So one of the things is we don't have an answer yet for it, but what we're probably going to do is at one point when the pain is there, we're going to actually figure out a way how to sync from our mono-repo some applications to our poly repos that hold our open source. So mono-repos are great for us. We love them. We love it, actually, not them because it's a singular. But we don't use them everywhere, actually, within our organization. If we don't use them anywhere, aren't we just using poly repos then, really? No, actually not. But one of the things that is outside of our monolithic repository is a company that we just bought called JobBoards.io. Why are they not within our mono-repo immediately? Well, they have different tooling. They are a Heroku shop. We are on AWS, and we have a very strict CI/CD pipeline. Does it fit into our pipeline? Does it fit into our directory structure? Not yet. So eventually, we will merge it into our mono-repo, but these things take time. So we do have some of those instances as well.
So, in conclusion, as Adam Jacob wrote in his article, Mono-repo, Please Do, we have to choose the repository structure that defaults, without any tooling, the behavior that we want to see in the world. In poly-repo, that behavior is isolation. That's the whole point of that. In mono-repo, that behavior is shared visibility. That's the whole point of that. In each case, we're going to be using tools to send off the sharp edges. But in ZipRecruiter, we believe in mono-repo because it instills the cultural values that we want in our developers. And we can see the outcome of that in the decisions and actions they do every single day.
So here are a few references that we used. We did a lot of research while doing this talk, and I actually like that there's a mono-repo please do and a mono-repo please don't. That's fantastic, and they're incredibly informative. We're not zealots, so choose the path that actually fits your culture.
Bring in the question. Yes.
Get someone, does that fit in with your architecture in some way?
It could possibly. I'm the problem with Git submodules. It's a commit that you put. You're actually inserting the commit within your Git repository. We're thinking about it. It's not painful enough yet for things that are external.
So with the third-party packages, dependencies, the different teams need different versions to manage that.
So actually, that's really interesting. What we try to do is, no, every team is going to use latest if we at all possibly can. Having said that, obviously that's not possible in every single situation. But we'll try to, if latest is broken, by the way, then we might not use latest, and we might pin it on the version that does work, and we've done that in the past. But everybody will use that. It's incredibly collaborative, and yeah, it has its challenges as well.
Okay. Do you use vanilla Git? And if yes, how long?
We use GitLab, and a whole bunch of Git hooks within GitLab.
Company, and you had the resources when you needed to create all of these great tools to help you with the mono-repo challenges like CI/CD and stuff like that. Don't you feel that for a beginner startup, it would just be easier to start with a poly-repo and everything will work until you can invest?
Maybe. So yeah, it depends on your culture, really. We've seen. I've worked at most of the companies I've worked at in the past. That's how we did things as a small startup. And yes, all the third-party tooling just works. It's a lot harder in a mono-repo. You have to actually put the effort in, and it might not be worth it. As you know, the whole Martin Fowler conversation, right? You have to put things where you have the most business value. And do you really have the most business value of starting to build all your tooling first?
Yeah.
Have you considered using a pull request mechanism for merging the code?
Greenlight is our pull mechanism for doing that.
Using GitLab's approach?
Yeah, but the GitLab approach, the GitLab tooling, doesn't use our directory structure, and it doesn't enforce our owner files. So if we use it, we'd have to create a whole bunch of tooling around that to make it use it. Greenlight grows with ZipRecruiter, and it will become even a greater part of our CI/CD tool.
So now so you have some change in your So now you went over your repo, did the grab on all the files, and did all the fixes.
and now you obviously manage to master, and then the artifacts are built. Right? So how did you handle the rollout of such check?
That actually happened, by the way. That's exactly the example of like Go. We had to update Go.
Yeah, if we want to refactor our code base, we can use one commit to affect all tooling, 1,000 lines of code in one commit. We can also roll it back using one commit.
Actually, last week, remember we did one that
talk about that.
that did like it did like 80 builds at one time. And
691 builds because we changed our base image.
Oh, that's right. We did change our base image.
So,
that's true.
Followed by deploys?
Yes, depends. We have a CD to Kubernetes. We don't have it to our EC2 instances. But yes, everything to Kubernetes was deployed at the same time. We ran out of time. You can catch us later. We'll be in the open office hours.